In the early hours of December the 1st, 2020, a cluster of steel cables on the north edge of a concrete tower gave way without warning. Not long after, a 900-ton instrument panel that had been suspended for nearly 6 decades lurched forward and fell. And just like that, the most productive radio telescope in the history of science ceased to exist, swallowed by the very dish that it had spent a century orbiting. These events unfolded in one of the most quietly devastating moments in the history of American science. This was no ordinary collapse, and one of the most devastating moments in the history of American science. The Arecibo Observatory was gone, leaving the world to question, of course, why the United States had decided it could no longer afford to keep the world's most powerful radio telescope alive. A question we'll answer on today's episode of Its History. So stay tuned as we uncover the rise and fall of the Arecibo telescope. I'm your host, Ryan Sokash, and you're watching Its History. In the late 1950s, a Cornell University physicist named William E. Gordon was preoccupied with the uppermost layer of Earth's atmosphere. Gordon wanted to study this region directly, and his idea to do so was bold. He wanted to fire a radar signal upwards and measure what bounced back, a technique that would let scientists map the density and temperature of the ionosphere in real time. The calculations, however, were punishing. To do the job he imagined at the frequencies he needed, the receiving antenna would have to be roughly 1,000 feet across. Yet, at the time, no structure that size had ever been built. For reference, conventional radio telescopes were dish-shaped structures mounted on gimbals that could physically rotate and tilt. A dish 1,000 feet wide, built that way, was structurally impossible. Instead of building a dish that moved, he proposed fixing the reflector permanently to the ground and suspending the receiving instruments above it on a platform. If the dish was shaped like a spherical bowl, the platform overhead could be repositioned along its arc, and in doing so, it could collect signals arriving from different angles of the sky. So to clarify, the dish itself would never need to move. So Gordon had an elegant solution, but he required the correct piece of terrain. Northern Puerto Rico fit the bill, since its geology is riddled with sinkholes, where the ground has dissolved and collapsed over millions of years, leaving the type of features that would perfectly fit the contours of this telescope. In 1959, an aerial survey identified one such sinkhole near the town of Arecibo that was almost precisely the shape of Gordon's design demands, a natural bowl, roughly 1,000 feet wide, pressed into the jungle floor. Now, at this point, I need to mention that the project came with an undisclosed motivation. The U.S. Department of Defense's Advanced Research Project Agency, the ARPA, the same body that would later build the early internet, funded the operation from the start. Do you guys see where I'm going with this? Ballistic missiles followed trajectories through the ionosphere on the way to their targets, and understanding how that charged layer affected the guidance systems of incoming atomic warheads had become militarily urgent. So by the summer of 1960, construction crews moved into the jungle above Arecibo. 3 years and $9 million later, the observatory opened. What they had built was unlike anything else on Earth. The reflector dish, 1,000 feet in diameter, was pressed into the natural sinkhole as planned, and lined with nearly 40,000 aluminum panels. Those panels rested on a web of steel cables strung between anchor points in the sinkhole's limestone walls. Above the dish, 492 feet in the air, hung the instrument platform. It weighed 900 tons. Yet, astonishingly, that feature was suspended by just 18 main cables, running from the top of 3 reinforced concrete towers. Each main cable was a bundle of 160 individual steel wires, encased in a painted outer sheath about 3 inches in diameter. Now, because Puerto Rico's tropical humidity was a constant threat to the steel, dry air was continuously pumped through the cable bundles. This prevented internal corrosion. With that said, the scale here is difficult to convey. So let me just put it this way. The dish was wider than the Empire State Building is tall. The telescope had been built for the ionosphere, but it quickly found other things to listen to. In 1964, just months after opening, a team pointed the dish at Mercury and measured how fast the planet was rotating. Back then, every textbook in the world said Mercury's days were 88 Earth days long, identical to its year, with the planet itself locked in a permanent face towards the sun. Though Arecibo said otherwise, the actual rotation period was 59 days. Turned out, those textbooks were wrong. And this was just the first of many demonstrations of what the telescope could do to establish knowledge. Think about that. Within just months of opening, the facility had effectively overturned a fundamental assumption about the inner solar system. And they didn't stop there. Through the late 1960s, the observatory continued mapping the solar neighborhood, producing the very first radar maps of the surface of Venus, probing the topography of the moon, and tracking near-Earth asteroids with a precision no other instrument could match. By 1969, ownership transferred from the Department of Defense to the National Science Foundation, as the facility was renamed the National Astronomy and Ionosphere Center. The military had funded its birth, but civilian science would come to define its legacy. In 1974, the telescope received its first major upgrade. Engineers replaced the wire mesh surface with precisely matched aluminum panels. They added S-band radar capacity and boosted the transmitter's output substantially, and it wasn't cheap. The cost was almost exactly what the original construction had required, another $9 million. Though it was probably worth it, as what happened next led to a Nobel Prize. Perhaps the telescope's most early dramatic triumph came courtesy of a 24-year-old Cornell graduate student named Russell Hulse, who in the summer of 1974 was cataloging pulsars, the collapsed cores of dead stars that spin so fast that they emit radio pulses with the regularity of a metronome. Though he noticed something strange. One of them was not behaving as expected. The pulse timing kept drifting in a pattern that made no sense for a lone spinning star. So Russell and his advisor Joseph Taylor worked through the math, and they landed on the one explanation that fit. The pulsar was locked in a tight orbit with another neutron star. The two objects were circling each other so fast that the motion was distorting the signal entirely. And this observation turned out to matter enormously. You see, Einstein's general theory of relativity had predicted that two massive objects in close orbit should slowly spiral towards each other, bleeding their energy away as invisible ripples in space-time. In other words, gravitational waves. Though it was Einstein's theory because no one had detected one. And so the Arecibo offered a workaround. Taylor's team tracked the binary pulse for years and confirmed that its orbit was decaying at almost the exact rate that Einstein's equation demanded. In other words, they delivered proof that gravitational waves were real. Another moment of note came in November of 1974, when scientists at the telescope transmitted something outward rather than merely listening inward. The message, a 1,679-bit sequence encoding a primitive image of the solar system, a human figure, and the telescope itself. This was all sent roughly 25,000 light years away, in what was the most deliberate attempt ever made by humanity to announce its existence to the universe. An action that was so unusual that the world took note. By the mid-1990s, Arecibo had crossed from the pages of scientific journals into the broader American imagination, and naturally, pop culture followed. In 1995, it starred as the cinematic set piece in the James Bond film, GoldenEye, its bull reimagined as a concealed Soviet installation. The following year, it also appeared in Carl Sagan's film Contact, but this time as itself. These were not accidental choices whatsoever. Arecibo had become the image people reached for when they wanted to picture humanity listening to the cosmos. And yet, at almost the exact moment the world was falling in love with it, the funding ran out. In 2006, the NSF implemented a budget cut across its division of astronomical sciences. With that, Arecibo's annual funding dropped from $10.5 million down to $8 million. The agency also began signaling that it expected other institutions to start chipping in and sharing the operational cost. Though, sadly, no partner emerged, and the situation continued to worsen year by year. Then, in September of 2017, Hurricane Maria made landfall in Puerto Rico with 155-mile-per-hour winds. The storm's eye passed directly over the observatory. This is when a line feed antenna broke loose and punched through the dish's surface, destroying roughly 30 of the nearly 40,000 aluminum panels. The damage was severe, but not catastrophic. The dish itself survived largely intact, and NSF announced that in November of 2017, it would like to continue operating the facility, but still, with steadily reducing contributions, ramping down from $7 million annually to $2 million over the following 5 years. So most scientists understood at this point that the message was clear. Arecibo was not going to make it. By 2020, the telescope's operating budget had been stretched past the point of adequate maintenance, and it was really beginning to fall apart. On the morning of August the 10th of that year, the cable on Tower 4 pulled free from its socket and fell across the dish below, tearing a 100-foot gash through the aluminum panels. Engineers assessed the damage and judged that it was manageable, but still, it was going to get worse. Then, on November the 6th, a main support cable on the same tower snapped without warning. So, at this point, 2 of the main 18 cables were gone, both connected to the same tower, with the remaining cable on Tower 4 carrying loads far beyond its rated capacity. Hence, structural engineers calculated that the probability of a catastrophic, uncontrolled collapse was significant and growing. And so it was. On November the 19th, 2020, the National Science Foundation announced that it had no safe path forward. The Arecibo Observatory would be decommissioned. And just as the controlled demolition was planned, fate intervened. On December the 1st, 2020 at 7:56 in the morning, the remaining support cables gave way at the same time. The 900-ton instrument platform dropped 492 feet in under 10 seconds, striking the dish below with a force that shattered the aluminum surface, toppled 2 of the 3 concrete towers, and sent a wave of debris rolling outward across the jungle floor. Furthermore, the falling platform tore the dome free and sent it tumbling down the hill as well. Drone footage captured the entire sequence, and when it circulated online, the response was immediate and visceral. Scientists who had spent their careers at Arecibo described watching that footage in a way that people describe witnessing death. Independent investigations later concluded that the root cause of the collapse was called zinc creep, the gradual, nearly invisible deformation of the zinc used to manufacture the cable socket fittings. This zinc creep unfolded over decades, maybe even longer. When you add that to extreme sustained loads and a tropical environment, disaster is almost guaranteed. So the structure was slowly failing for years, but visual inspections could not have caught it. And it should also be noted that even the original design margins had always been smaller than the engineers realized. In 2022, the NSF announced formally that the Arecibo telescope would not be rebuilt, though an educational visitor facility would be established on the site. And interestingly, the dish remains in the sinkhole, now cracked, overgrown, and returning to the jungle. And we'll leave it there for today, but a special thanks to the viewer who submitted this video idea. If any of you out there know of a special story that you'd like us to cover, please share it in our community tab on YouTube. I do check that from time to time. Otherwise, as always, this is Ryan Socash signing off.